right, on to page 7 of the Term 2 exam review, and this gives us a graph here, and they ask us a whole bunch of information off of that. First one, what's the limit as you approach -1? So as we come towards -1 from the left and the right, we're coming to a value of 3. What is g of -1? That's where the dot actually is, and that's at +1. G of 3 is where this is located at 3, and that's down here at -2. G prime -3 is the slope at there, and you can see we have a sharp turn. Because we have a sharp turn, that's undefined. Cannot say with any certainty what the slope of a tangent would be at that spot. As we approach 2 from the left side, as I come at 2 from the left side, we're coming at this dot here, which is at 3. But if I'm just saying in general, what is the limit at 2? I have a disagreement. I have a jump discontinuity here. So that limit does not exist. G prime 2.5. If I'm at 2.5 and I'm looking for the derivative, it would be the slope of this line. This line goes down 1, 2, 3, 4, and over 1. So it has a slope of -4. H says, is G double prime -3 positive, negative, or 0? So at -3, you can see that this graph is concave down slightly. And so the second derivative would be negative because g, the function, is concave down at that spot. I says, what's the limit of this? Now this is that definition of the derivative at a point. So really what this is saying is what is the derivative at 4? And at 4, you can see the derivative is 0. But if you were to put 4 in, you'd get 0 over 0, which would tell you to do L'Hopital's rule, which would give you g prime x. This goes to 0, this goes to 1. So it would be the derivative of g at 4. So hopefully you'd get it through that way too. Where is g not continuous from -4 to 4? So I'm looking for any discontinuity. You can see we have a little hole in the graph at -1. We have a jump discontinuity at 2. So at x equal -1 and at 2. 3 is still continuous. It's not differentiable, but it is continuous. So when we get to k and it says, where is g not differentiable? It's those two places still. Anywhere it's not continuous for sure. But then that sharp turn at 3 gets added on to that as well. All right, then we were given a graph. This is the graph of f prime. So we got to keep that in mind. We're talking about the derivative of f now. Where is f increasing? F is going to increase when its derivative is positive. This is the derivative, and it's positive from -2 to 0. Where is f at its maximum? So if you think about it, we're increasing. We have a positive derivative here, so we're increasing until 0, and then decreasing afterwards. So where will it be at its maximum? At x equals 0. Where is f at its minimum? Well, if we were increasing until here and then decreasing afterwards, the minimum would have been either when we started or when we finished. Really we're not able to really say at this point which one that is. So we'll just say it's -2 or 2. Is f differentiable? Now this is a trick question because you see the sharp turns here, and so you might say no because of the sharp turns, but this is not f of x, this is f prime. And we do have a derivative value, whatever this height would be, whatever that height would be, we do have derivative values for that. So is f differentiable? Yes. F of -1 and f of 1 exist, are defined. But if you were to say f double prime, or is f prime differentiable, we would say no. It's a little bit of a trick question there. Where does f of x cross the x-axis? No clue. I don't know. This is how f changes, but where f is, no idea. It could be 100 miles above the x-axis. It could cross it a bunch of times. I have no idea. Okay. Where, if any, does f have an inflection point? Now that we do know, because when the derivative is decreasing, f is concave down. And when the derivative is increasing, f is concave up. So when we have that switch from concave down to concave up, we have a point of inflection. That'd be at x equal 1. 32 wants us to find the critical numbers of this function. So there's two ways you can do this. You can do a product rule when you take the derivative of this, or you could just distribute this. 3x to the fourth minus 4x cubed. Now let's take the derivative, which is 12x cubed minus 12x squared, and let's set that equal to 0. Critical numbers where our derivative is 0 or undefined. I'm going to pull a 12x squared out, leaves me with x minus 1, and so x equals 0 or 1. Those are our critical numbers. Now, and that ends up being b. That doesn't mean that they're necessarily relative max or minimums, but they are definitely critical points, things we should be looking for.